Chapter 3, Section 3, Solving Right Triangles. What does it mean to solve a right triangle? Well, it just means figure out everything there is to know about that triangle. So if there are any unknown lengths, we want to determine those. Any unknown angles inside, we want to determine those as well. Now, as is often the case with these types of problems, there's more than one way of getting the result you're looking for. So sometimes you could find 2, 3, 4, or 5 or more different methods of getting to the same answer. So for this video, I'm going to solve the same right triangle twice, showing you 2 different methods. Now, because I can't fit everything on one slide, everything that I write in this area here on your notes, you should write down here. And the same goes for method 2. All right, let's begin. We want to determine AC. Let's do that first. Well, that is the length from here to here. Right there. So if I say AC, that's the length I'm referring to. All right. Well, let's use what we know. Okay. This is 32 degrees, and this is the hypotenuse. That is 10.4. We call this an angle of elevation because the bottom of the triangle is horizontal, and the hypotenuse just goes diagonally like so. So we can fill this in here. Because this triangle here is an example of this diagram. This angle here is what we call an angle of elevation. So this is the adjacent. That's the hypotenuse. We use cosine. So cosine of 32 degrees is adjacent over hypotenuse, thanks to SOHCAHTOA. So let's solve for AC. So just multiply both sides by 10.4. So that means length AC is going to be approximately, work it out, 8.82. So that's to the nearest hundredth. Now there are no units necessary because there are no units given in the problem. Moving on, we want to determine this length here, BC. All right. Well, we can use this angle 32 degrees and this hypotenuse 10.4, but because BC is opposite to this angle right here, we can use the sine ratio. So the sine of 32 is opposite over hypotenuse. Right? So it's actually pretty much the same as the last one, only we're using sine instead of cos. That's okay. All right, so 10.4 times the sine of 32 is approximately 5.51 to the nearest hundredth. All right, so we now know the lengths of all 3 sides. So there's only one more thing we need to figure out, and that is this angle right here, angle ABC. ABC. So this unknown angle I'm going to call theta. So let's work that out. That's pretty simple. 180 degrees minus 90 minus 32 will give us this unknown angle here, theta. Because all 3 angles of any triangle have to add up to 180. All right? So 180 minus 90 is just 90, and 90 minus 32 is 58. All right, I'll put that here. All right? So we now know everything there is to know about this right triangle, so we can say now that it has been solved. Okay, so let's just solve the same triangle again, but do things slightly differently. All right, well, what I'm going to do is I'm going to go for this angle first. Why not? So we've already figured out before that that was 58 degrees. just by the fact that 180 minus 90 minus 32 is 58. But I'm going to use this angle instead of this angle down here to figure out some of these missing sides. So, which should we do first? Now let's do this one. Okay. Again, that's AC. Okay. So the hypotenuse is still, of course, 10.4. But if I use this angle, 58 degrees, AC is the opposite. So that's going to require the sine ratio. Okay, so here, I'll just keep this in blue. So theta was 58 degrees. So let's label that here. That was theta. So the sine of 58 degrees is opposite over hypotenuse. All right. Just going to squeeze this in. It's a little tight. There we go. So AC. So 10.4 times the sine of 58. What do you know? I get 8.82. Again. Okay. So the only thing we have to figure out now is BC. We already know what it's going to be, but let's do it a different way. I'm just going to change color here. Let's use this one. So we need to figure out the length of BC. All right. If I use this as my angle here, all right, BC would be the adjacent, and 10.4 would be the hypotenuse, so I could use cosine. But don't forget, I already know what AC is, because I just figured it out. So I actually could use the tangent ratio. In fact, I could use any ratio I want. All right, so the tan of 58 degrees is the opposite, okay, which is AC, divided by the adjacent, and the adjacent is BC. Okay? All right, well, BC is on the bottom, so if you do the algebra, I'm just going to skip those steps because I've demonstrated it many times before. BC is just going to be 8.82 divided by the tan of 58. Okay. So let's work that out. And of course, as expected, I get 5.51. Now here's the only thing you just have to be mindful of. In my calculation here, this 8.82, this was a rounded value. Okay, so this isn't quite precise. So when you're working with this calculation, what I did is I actually kept a few more decimals after this. That's what I actually used. I just didn't write it down. Okay, so if you actually do 8.82 exactly as written, divided by tan of 58, okay, well, you still get 5.51. But you just have to be mindful that if you're using numbers that are rounded, you don't want to round them too much because, well, by the time you get the answer you're looking for, you might be slightly off. Okay? But in this case, it all worked out. Solved.